Imagine standing on a quiet shoreline at night, gazing across an ocean so vast that its far side disappears into darkness. Beyond the horizon lies an unknown world, hidden from view but filled with possibilities. For thousands of years, humanity has looked at the stars in much the same way. We have wondered what exists beyond our cosmic horizon and whether somewhere among those distant lights another world like Earth might be waiting to be discovered. Today, thanks to remarkable advances in science and technology, that ancient curiosity is becoming a powerful scientific quest. At the center of this effort stands one of the most sophisticated observatories ever built, the James Webb Space Telescope. The James Webb Space Telescope represents a new era of exploration. Unlike traditional telescopes that primarily observe visible light, Webb is designed to study the universe in infrared wavelengths. This allows it to peer through vast clouds of cosmic dust, observe some of the earliest galaxies ever formed, and investigate distant planetary systems with unprecedented precision. Since its launch, Webb has transformed astronomy. Its golden mirror, stretching more than 6 meters across, collects faint light that has traveled for billions of years through space. Every observation provides scientists with valuable information about how stars form, how galaxies evolve, and how planets develop around distant suns. Among the countless worlds scattered throughout our galaxy, one planet has captured the attention of scientists and the public alike: Proxima b. Proxima b orbits Proxima Centauri, the closest known star to our solar system. Located approximately 4.24 light-years away, this neighboring star system sits practically next door in cosmic terms. Although the distance is still enormous by human standards, it is close enough to make Proxima b one of the most studied exoplanets ever discovered. The planet was first identified through careful observations of its host star. Astronomers noticed tiny movements in the star caused by the gravitational pull of an orbiting planet. These subtle shifts revealed the presence of a rocky world roughly similar in mass to Earth. What immediately made Proxima b so fascinating was its location. The planet orbits within what scientists often call the habitable zone. This is the region around a star where temperatures may allow liquid water to exist under the right conditions. Because water is considered one of the essential ingredients for life as we know it, planets within this zone become especially interesting targets for study. However, being located within the habitable zone does not automatically make a planet habitable. Proxima Centauri is a red dwarf star, a type of star smaller and cooler than our Sun. Red dwarfs are the most common stars in the Milky Way, making up roughly 70% of the galaxy's stellar population. Because they are so abundant, understanding the planets that orbit them could dramatically increase our knowledge of potentially life-supporting worlds. Yet red dwarfs also present unique challenges. Unlike our relatively stable Sun, many red dwarfs are highly active. They can produce powerful stellar flares capable of releasing intense bursts of radiation. These eruptions may strip away planetary atmospheres or create harsh conditions that make life difficult to sustain. This uncertainty has made Proxima b one of the most intriguing mysteries in modern astronomy. Does the planet possess an atmosphere capable of protecting its surface? Could liquid water exist there? Has the world managed to survive billions of years of stellar activity? Or is it a barren landscape exposed to relentless radiation? These questions are precisely the kind that astronomers hope powerful observatories like Webb can help answer. Although the James Webb Space Telescope cannot currently provide detailed photographs of exoplanet surfaces comparable to images of Earth or Mars, it can analyze the faint light associated with distant planets and their environments. By studying how light interacts with gases surrounding these worlds, scientists can identify potential atmospheric components and learn more about their characteristics. This technique, known as spectroscopy, acts like a cosmic fingerprint scanner. When light passes through a planet's atmosphere, certain wavelengths are absorbed by specific molecules. By examining these patterns, researchers can search for substances such as water vapor, carbon dioxide, methane, oxygen, and other important compounds. Each detection adds another piece to the puzzle. Instead of simply knowing that a planet exists, scientists can begin constructing a picture of what conditions might be like there. Is the atmosphere thick or thin? Is the climate potentially stable? Are there signs of chemical processes that resemble those found on Earth? The answers often raise even more fascinating questions. One of the most exciting aspects of modern astronomy is that we are gradually moving beyond the discovery phase of exoplanet science. During the 1990s and early 2000s, astronomers were thrilled simply to confirm that planets existed around other stars. Today, thousands of exoplanets have been identified. The challenge has evolved. Now researchers want to understand these worlds in greater detail. They want to investigate their weather systems, atmospheric chemistry, geological activity, and long-term evolution. The James Webb Space Telescope is helping make that transition possible. Every observation contributes to a growing database that improves computer models and expands our understanding of planetary systems. Even when data do not reveal evidence of life, they still provide valuable insights into how planets form and change over billions of years. Perhaps one of the most profound aspects of this research is its impact on humanity's perspective. For most of history, Earth was the only known world capable of supporting life. The stars were distant points of light with little connection to our everyday experience. Today, however, we know that planets are common throughout the galaxy. Many stars possess entire planetary families. Some worlds are giant gas planets larger than Jupiter. Others are frozen ice-covered bodies orbiting far from their stars. Some are scorching hot worlds where temperatures can melt metal. And among them may be rocky planets with conditions suitable for oceans, clouds, and perhaps even living organisms. The possibility that life could exist elsewhere no longer belongs solely to science fiction. It has become a legitimate scientific question. That does not mean evidence of extraterrestrial life has been discovered. Scientists remain cautious and rely on rigorous analysis before drawing conclusions. Extraordinary claims require extraordinary evidence. Nevertheless, the tools available today are more powerful than ever before. Future observatories currently being planned may eventually detect direct signs of biological activity on distant planets. Researchers are developing concepts for telescopes capable of examining Earth-sized worlds with even greater sensitivity than Webb. These next-generation instruments could search for combinations of atmospheric gases that may indicate biological processes. They might reveal weather patterns, seasonal changes, or even surface features on nearby exoplanets. In many ways, the James Webb Space Telescope serves as a bridge to that future. Its discoveries are laying the foundation for decades of exploration to come. The implications extend far beyond astronomy. Questions about life elsewhere touch on philosophy, biology, history, and our understanding of humanity's place in the universe. Every new discovery invites us to reconsider what it means to live on a small planet orbiting an ordinary star in a galaxy containing hundreds of billions of others. Perhaps somewhere among those countless stars, another civilization is asking similar questions. Perhaps worlds like Earth are common. Or perhaps our planet is exceptionally rare. At present, we simply do not know. What we do know is that humanity has entered an extraordinary period of discovery. With each observation, each dataset, and each breakthrough, we push a little farther into the unknown. The James Webb Space Telescope is helping illuminate that path, revealing a universe more complex, more beautiful, and more mysterious than we ever imagined. And as we continue searching the skies, one truth becomes increasingly clear: the story of exploration is far from over. In many ways, it has only just begun.